Hey everyone, today, we're diving deep into something super exciting, an epic journey through the history of chemistry, from 450 BC all the way to 2024. So, buckle up, we're going to explore everything from ancient alchemists trying to turn lead into gold to today's cutting-edge discoveries that might just change the world. The history of chemistry is a fascinating journey that reflects humanity's quest for understanding the natural world. Evolving from mystical practices to a rigorous scientific discipline. Let's break down this history into several sections. From 450 BC, 1600 AD, foundations of alchemy. Around 450 BC, Greek philosophers like Empedocles and Democritus proposed early ideas about matter. Empedocles introduced the four classical elements, earth, air, fire, and water, while Democritus suggested that all matter is composed of indivisible particles called atoms. By the 1st century AD, alchemy emerged, blending philosophy and proto-science in ancient Egypt, China, and India. Alchemists sought to transform base metals into gold and discover the elixir of life. Figures like Jabir ibn Hayyan in the Islamic Golden Age advanced alchemical practices, emphasizing experimentation and introducing techniques like distillation and crystallization. From 1600 to 1800, the birth of modern chemistry. The Renaissance marked a turning point for chemistry. Robert Boyle, in the 17th century, rejected alchemical mysticism and emphasized empirical evidence. His work, The Skeptical Chemist, laid the groundwork for modern chemistry by advocating the scientific method and formulating Boyle's law. Antoine Lavoisier in the late 18th century revolutionized chemistry by establishing the law of conservation of mass, debunking the phlogiston theory, and introducing a systematic chemical nomenclature. He identified oxygen and hydrogen, setting the stage for modern chemical reactions. From 1800 to 1900, the age of discovery, the 19th century was characterized by significant advancements. John Dalton's atomic theory, 1803, proposed that elements consist of atoms that combine in fixed ratios. Dmitry Mendeleev developed the periodic table in 1869, organizing elements by atomic weight and properties, which helped predict undiscovered elements. The discovery of new elements, such as aluminum and the noble gases, alongside advances in organic chemistry by chemists like Auguste Kekulé, who proposed structural formulas for organic compounds, transformed the field. From 1900 to 1950, the quantum revolution. The early 20th century ushered in the quantum era. J.J. Thomson discovered the electron in 1897, challenging existing atomic models. Ernest Rutherford's gold foil experiment, 1909, revealed the nucleus, leading to Niels Bohr's model of the atom. The development of quantum mechanics further advanced chemical understanding, enabling the explanation of atomic behavior and bonding. Linus Pauling's work on chemical bonding in the 1930s laid the groundwork for molecular biology. From 1950 to 2000, biochemistry and materials science. The mid-20th century saw chemistry intersecting with biology, leading to biochemistry's rise. The discovery of the DNA double helix by James Watson and Francis Crick in 1953 marked a milestone in understanding genetic material. Materials science emerged as a critical field, leading to innovations like plastics, polymers, and superconductors. Green chemistry began to gain traction, focusing on sustainable practices and minimizing environmental impact. From 2000 to 2024, modern challenges and innovations. In the 21st century, chemistry continues to evolve, addressing pressing global challenges such as climate change, energy sustainability, and health crises. Advances in nanotechnology and synthetic biology hold promise for revolutionary applications, while ongoing research into pharmaceuticals and materials science strives for more sustainable solutions. Chemistry's role in interdisciplinary fields, such as environmental science, pharmacology, and materials engineering, reflects its foundational importance in addressing complex global issues. As we look to the future, chemistry remains a vital science, bridging gaps between disciplines and pushing the boundaries of human knowledge. Thanks for watching, and remember, science is everywhere. Until next time, keep exploring and experimenting. Keep an eye out for the latest updates coming your way.